Hi everybody, in today's video we're going to talk about coordination chemistry. I hope you like it, so let's start. Coordination number 4. The most common structure with this coordination number are tetrahedral and square plane. And the first is the most frequently observed structure, and the distortion are attributed to steric effects or crystalline packaging. In some cases for electronic purposes, for example, tetrachloroplatinate shares -2. And in the second structure, square planar, they are rarer than tetrahedral and are associated with 8 electrons in their valence shell. For example, tetrachloroplatinate shares -2. Number 5. This type of geometry occurs when 5 ligands surround the metal center, and usually geometries are trigonal bipyramide and square base pyramid. Coordination number 6 is the most common coordination number, and octahedral is the most common structure. However, trigonal prints are also known. Compounds with this coordination number arise from transition metals with 8 or 6 electrons in their valence shells. Octaedric geometry is a metal ion slash dual of 6 ligands around. For example, examine cobalt shares +3. In some cases are observed tetragonal distortion for metals with configuration D4 and D9, but it can be explained for Jahn-Teller effect. In trigonal prints structures, most compounds with this type of geometry have 3 evidenced in there. Now I will show you some examples of the basic nomenclature. If we have a single ligand like this example, we put the name of the ligand with the times that are repeated. If they are 2, is D. Would be diamine, and then the central atom with a charge would be diamine silver 1. For coordination compounds that are ionic, the cation is named first and separated by space for the anion, like this example. What is the cation? Is potassium, and the anion is bromo. Would be potassium tetrabromo, and then the central atom with a charge, potassium tetrabromo cuprate 2. One more example. We have 2 ligands. It's in alphabetical order. The aqua will go first, and then the cyan. Also, the metal will end in 8 because it's an anion. The name will be aqua pentacyan ferrate 3. Electronic structure of the complexes. The properties of the complexes are the products of their electronic structure. For this reason, different theoretical models appear to try to explain the behavior in the complexes. First appears the theory of the crystalline fields that explain the color and the magnetic properties of the complexes. Then, the valence bonds theory, which tries to explain the bonds in the compounds. And finally, the theory of molecular orbitals is a consequence of the valence bond theory. Theory of a color. The color of a complex depends on the metal oxidation state and its ligand. Also, the presence of a sublayer D partially filled in the metal is necessary for a complex to show color. Then, that radiation possesses the energy it takes to bring an electron from its lowest energy state into an excited state. The energy is inversely proportional to its wavelength. Here are the formulas. For example, the orange and the blue are complementary colors because in the world they are opposite. So if an object has a specific color, it's because it transmits light of that color and at the same time absorbs light of the complementary color. Complementary color can be determined using a color wheel.
You must need a certain amount of metal to function normally. Most metals are used covalent or prosthetic, and enzymes catalyzing a specific reaction and serving essential rules. The essential rules metal for humans are potassium, copper, chromium, vanadium, zinc, platinum. Anemia symptoms are caused by lack of certain metal. Anemia can be associated with malnutrition or genetic defect. Examples of specific types of the metal. Anemia include iron, common simple anemia, iron deficiency, result in the low dose. Metal in treatment. Metal has been used in treatment science in the times. That ever procured from 1500 by C is a fair variety cause of the used metal for treatment. Describe the use of the copper to reduce inflammation and the use iron to treat anemia. Cisplatin is the best now among metal pharmaceuticals because it is used to treat cancer.
Thanks for watching this video. I hope it's helped you, and give me a like if you liked this video.